So it looks like we don't have any questions. So you guys are all super confident in your knowledge of the concepts from the last lesson, I hope. That's what that tells me. But let's get started with tonight's lesson. Let me share my screen and we can get going. Okay, so let's jump into TK real quick and see what we're going to be talking about tonight. Our objectives tonight are going to be, we're going to talk about schema design tonight and how to actually create a database. In the last lesson, we kind of used a database that was already there for us, but we're going to talk now tonight about designing and building our own database. So by the end of this lesson, we're going to be able to use SQLite Studio, which is a GUI that allows us to get a visual representation of what's going on in our database file there. We're going to explain what a database schema even is, which, you know, this might be a first time you've heard the term schema before. Then we're going to create a schema using Connects migrations. So we'll get into what that is, what migrations are, and why they're important for us to use. And then also we're going to pre-populate our database using seeds. And so we're not going to be messing a whole lot with like Node and Express tonight. We have a server that's pre-built for us, and we're going to be focusing purely on the database side of things. So before we get started, let's kind of talk about what a database management system is. And let's go, I'm going to create a new thread here. Let's go, that's fine. And you're going to see it as RDBMS. I know it says DBMS here. And that's going to be all database management systems, but let's talk about all database management systems. So thread here for that. So just in your own words, if you've gone through Training Kit, done your Training Kit prep, who can tell me what a database management system is? What that even means? Let's just build tables, manage how the data is structured. Yep. Anyone else? Cool. Yeah. Software for creating and managing databases, place to create, hold, manage the data, allows us to interact with the database. Yeah. So I was trying to come up with a good analogy before class today of what a database versus a database management system is. And really the only thing I can kind of come to think of with in the tech world is like the difference between your hard drive and your operating system, right? You can access your hard drive on your computer using your operating system. Can you access the data on your hard drive without using an operating system? If you're like a crazy, like super low level language programmer, you might be able to. But for the most of us, we like that operating system on top of our hard drive because it gives us this graphical interface. It allows us to have the knowledge of how to use it, how to access that data. And that's the same thing with a database management system. We're going to have our database, which is really just, I mean, in our case here, it's going to be a single file for SQLite. In other cases, it might be some data stored on a server somewhere. And our database management system is essentially our operating system on top of that database. So it's going to allow us to access that data, to manipulate that data, and it's going to allow us to do whatever we need to do with that. And so we kind of talked about it a little bit on Tuesday, what the different database management systems are. And so when we say something like Postgres or SQLite, we're not really necessarily talking about the database itself, but the management system on top of it. And so, like operating systems, let's just use Windows versus Mac OS versus Linux, right? Those are three different operating systems, and they all kind of work in the same way, but they all have their own unique differences, right? And the same goes for database management systems. They're all going to, in our case, when we talk about relational database management systems, they're all going to use SQL. And we know we're going to be able to use a select, from, where, order by, limit, insert, into, delete, update. We're going to be able to use those basic SQL commands, but there are going to be some small differences when it comes to those different systems, and we're going to see some of those differences today when we talk about things like types. That's probably your first introduction to the differences between the systems. But then a lot of, just like an operating system, like Windows versus Mac, let's say, there are built-in stuff in Windows that's not available on Mac. And the same thing, there's built-in stuff on Microsoft SQL that's not available on Postgres, and vice versa. So this idea of a database management system, so you kind of, the two get kind of convoluted as we talk about them, and you'll have someone be like, oh, what's your database? And you're gonna be like, Postgres or SQLite, and then you're like, oh, that's actually your database management system. But yeah, we know what you're talking about. But it's important to understand what this management system is on top of it. So it's this software that's running our database for us. All right, that's why, here we go, database management system. Okay, so in our class, we are going to be using SQLite. And SQLite, the reason we use it, and I had mentioned this on Tuesday, is because it is almost identical to every other RDBMS, except that it's really easy to set up. Whereas all other database management systems, there's a bit of a time it takes to set those up and set them up properly, and there's a lot of things that could a lot of issues that you could run into, and we want to bypass that and get right to writing code. For the most part as well, you're not going to be setting your database up. You will in class, you will in labs, you will in your until you get a professional job. And then at that point, you're going to have a database administrator who's in charge of setting all that stuff up, granting permissions to users, giving you access to the database, things like that. And you're really going to be working with one of these kind of abstractions, like even PG, which is raw SQL. That's still an abstraction from the actual database itself, right? And so we want to focus on getting to the core of it. And like I said, in labs, you will be able to use something like Postgres with Heroku. Is pretty simple as well, but we're not able to distribute that like we are a SQLite file. So let's look at SQLite real quick. SQLite homepage. What is SQLite? And SQLite is according to the SQLite website, is the #1 database management system or engine in the world. Can anyone tell me why SQLite is the #1 database engine in the world? It's right on here. And we can just use that DBMS thread to go for that. It's free. Yeah, #1, it's free. It's the most used, so I was kind of getting for this this idea that it is installed in every single mobile device in the world, and the reason is because it's portable. It's really portable, and that's the reason we use it here. Is that because I can send you a SQLite 3, that .db3 file, and you can now have my entire database. All right. You can also ship a .db3 file with your application, and automatically your application has a database. Whereas something like Postgres or MySQL or MS SQL or any of that kind of stuff, those tend to be centralized databases that applications talk to over the internet. Or a network. And so the SQLite thing is awesome because it's portable, it is free, it's super lightweight, and it really, I mean, if you talk to any mobile developer, they'll talk to you. They're probably using SQLite in their app. I get a lot of students that are like, why aren't we learning Postgres right off the bat? And it's because we don't need to, and also because the fact that we can distribute a SQLite database to you very quickly and easily. So that's SQLite. You can read more about it on here if you'd like to. It is open source. Number one database engine in the world. I don't even believe they call it a management system. Because it isn't a management system. It is an engine. Okay. So it's kind of a mix between the two. Let's go look at something like Postgres. So Postgres, if you have been around the block for a little bit, is kind of the new hot database. I don't want to call it like the hipster database, but it really is. It's like everyone's using Postgres now. And the reason everyone's using Postgres is because of a couple of things. Number one, it's free, it's open source. Number two is that it has support for a data type that allows us to write JSON to our database, unstructured JSON. Whereas we're going to talk about types in a little bit. That's kind of a big thing. That's kind of a departure from our standard SQL database type of thing where we need a specific type. And so it kind of took the best of Mongo, which is almost completely unstructured. It's called a document store. And it took the best of something like MySQL and it combined them together. So it's really popular. It allows us to store tons of information. It allows us to store unstructured information as well. Which is popular when we have these data heavy applications that we're currently seeing in the world and we'll continue to see forever. Another super popular database system is MySQL. MySQL was kind of the go-to for a long time and still is for a lot of developers. It is probably the number one database management system used by PHP developers. You can kind of see their like like YouTube, PayPal, LinkedIn, Facebook, Twitter, eBay, they're all using MySQL. It was and still is a massively popular system. It is not open source. So that is one thing to keep in mind. It is owned by Oracle. So that is kind of one downside, I guess you could say, to it, although that might not be a downside if you're a corporate lawyer or someone that's really invested in enterprise and keeping your systems, you don't have this kind of open source community, when updates are happening, when patches are happening, who to reach out to, that type of thing. So there's just kind of some different uses. But MySQL is free. There is an enterprise edition that I believe is not free, but for most of developers, they use the normal standard free edition for MySQL. And you can download and set up a MySQL database system or Postgres on your computer for free as well. Then there's some others. Oracle has their Oracle database, which is a relational database that uses SQL. It's very much not free. But also intended for very large enterprise clients. There is Microsoft SQL or SQL Server, which is intended to be used on Microsoft products. And there are others as well. We saw on Connects that there's Amazon Redshift, I believe, is a database. Let's go to the top. Redshift, Oracle, Microsoft, MySQL, Maria database. So there are a number of other database management systems that we could be using, but like I said, SQLite is nice and portable, and it allows us to distribute our database quick. Okay, questions on database management systems? You can throw it right in there in the DBMS. Let's move over onto a graphical user interface that we're going to use with SQLite called SQLite Studio. So I have one open. Unfortunately, SQLite Studio does not allow me to make the text bigger, so I apologize for those of you with smaller screens. I tried, but to no avail. Also, it was a funny thing. I've had this downloaded and I've used it in the past, and then just went to use it again today, and I got a security warning on it. I don't really believe that that's necessary, but it might be something you run into as well. But for our case right now, we should be fine with it. Cool. So SQLite Studio is going to allow us to load in a SQLite file. In that SQLite Studio thread, who can tell me what a SQLite file is and what the file extension for a SQLite file is? SQLite 3, I should say, because this is 3 that we're using. It allows us to open any SQLite 3 file. For those of you in the DBMS, which I still have open as well, we're now in the SQLite Studio thread, which I'm closing the DBMS thread. Yes, so it is .db3, which I'm assuming stands for database 3, and the 3 stands for SQLite 3. So yeah, we can load up any SQLite 3 file that we want, and we have access to it, and we can manipulate it as well. So I'm going to go to database, add a database. I am going to click on the folder here. We can create a new database, which we will using the plus, but we're going to load one up real quick. I want to, yeah, we can go, we'll open this up. We'll open it up. This is the database that we are going to be using for our guided project tonight. And then you can test it if you want. This is more for loading something from a server to test the connection, or if you need a username password type of thing. And we're going to press OK. So now we have, and I'm sorry, the text is so tiny. Let me see. I can't zoom in at all. Nope. So now we have the database here, and we can see even then it says it's SQLite 3 database. So let's double click that. We're going to get a drop down, and we're going to have tables and views. And we're not going to talk about views right now. Views are essentially temporary tables that we can create that aggregates tables and queries for us automatically. But let's go into our table. We'll see that we have one table in here called fruits. And if we double click that, we're going to get fruits loaded up into our SQLite Studio here. So in the SQLite Studio thread, who can tell me one of the fields on the fruits table? Just one of the fields. ID, name. Yep, those are 2 of them. Color, average weight, ounces, data type. No. Ooh, that's okay. Yes, Teresa, that's a good thing to bring up. Data type isn't a field on it actually. So let's learn how to read the SQLite Studio. So what we see here is we see essentially a description of our table, and we have a lot of data here about this table. On the left here, these are the fields on the table itself. So not to be confused with these these columns up here. So the table itself is going to have an ID, name, average weight, ounces, delicious, and color field to it. These are just ways for SQLite Studio to describe what they're talking about to us, and we'll see this in a minute. So these are our fields: ID, name, average weight, ounce, delicious, and color. I'm going to get back to our types and some of the other stuff going on in here, but let's kind of go to our data. And now, I really think that there's a zoom somewhere. So now we can see this a little bit more. This is what we expect to see. is as our table. This is our table kind of in action as it is right now. Now we see that our fields are in the place that we expect them to be, right at the top there. ID, name, average weight, delicious, color. And then we can see that we have 1 through 5 IDs. We have the names. We have our average weights. Delicious, I believe this is probably going to be a Boolean. And let's go. Yep, it is. That's why it's a 1 or a 0, because 1 is true, 0 is false. And then we have a color as well. Let's go look at our DDL here. So this is actually DDL's data description language. And we are going to see how this table was created. We are not going to write our own SQL to create our tables, but you can go in and check it out. We're actually going to use connects to create our tables. But you can see how this table is created. You could actually copy paste that, plug it into another database, and it'll create this exact table for us. All right. So let's take a moment and let's talk about what a database schema is. New thread, who can tell me in your own words what a schema is? In this new thread, just in your own words, super high level. Structure, format, blueprint. I like blueprint. Yeah, it's the shape of something. It's what our database is going to look like. So in our case here, we have a single table, and really the structure here. This is kind of our schema. Okay, and there's when we get into creating multiple tables and linking them by using IDs and foreign keys and things like that, we'll have multiple tables. And there are a lot of applications out there that allow you to design a database in the table structure like this, and then it pops out the actual SQL code you can write. But let's go through and talk about the schema and the structure of this table. So far, we've really only talked about the idea of a field and a row or a record. But there's a lot more data and a lot more or structure that goes into a table than just the field. The first thing we're going to notice is the type. Not getting too deep into it and out of scope of the lesson, but relational databases, especially using SQL, rely on a data type. This does a number of things for us. Number one, it does a type checking for us, so we know if we're entering the right data or not. Number two, it actually assigns space on your disk or your memory for this type of data. Okay, so you're going to see something like varchar 128. So it's going to give us 128, not bits, must be characters, 128 characters. I don't know why I lost that. So it pre-allocates space for us. All we need to know, though, is what the type is going to be. So when we set out to design a database table, first things first, we should really think about what fields it needs, right? And we're like, okay, what information do we need to store about this record? In the case here, we have a name of the fruit. We have the average weight in ounces of the fruit. If it is delicious or not. What fruits? I wonder what fruits it says are not delicious. Durian is not delicious. That's subjective, right? I've never eaten a durian. I know it smells awful, but I hear people enjoy it. I don't know what a golden gooseberry is. I've never eaten one of those, but apparently it's not delicious either. But these are the things we have to think about first, right? What data? What is the data that we need to store? The second thing is what is that type of data? And so we see here that we have used the type of text for name. And let's pause right there for a moment. And I'm going to come back over here. and let's talk about types. This is going to be our first foray into the differences between database management systems. So for the most part, our types are going to be similar, and the major ones are going to be shared across database management systems, but there are differences. So it really is important that when you assign a type, that you assign it based on the system that you're going to be using. Okay. We're just going to go with the MySQL data types right here, and I want to show you the different types that are available to us. Character, a fixed length string. Okay, so we have to have a character of that size. It is a fixed length string. All right. Variable character, which gives us the size, and we're going to see variable character used quite a bit for strings in databases, but it's going to be up to the size we give it. All right. So it's important too, then when you assign something a variable character type or varchar type, that you think about what the string is going to look like. In our case here, the color, we said we're going to give it up to 128 characters. Okay. And for the most part, I don't think 100. I think 128 might be overkill, but it allows us to pre-allocate 128 characters for the color here. And we can go through and see all kinds of different types we can give it. All right. And it's important when designing a database to give it an accurate type that's going to save on memory, it's going to save on space, it's going to allow the database to run faster, it's going to give you more control over the data that you input into it or your user inputs into it. So it is important to give it the proper type. Something like text is awesome because it's just our general catch-all, and that text is not available on all databases, and it might be called something different on another database, but it is available on SQLite 3 and MySQL. We have numeric data types. So let's come in here and let's see some numeric data types that we are using. We're using the float data type. Let's just go deny on that for now. We're using the float data type. Can anyone tell me in very simple words what a float is? Boom. Ryan got it right off the bat. A float is just a number with a decimal in it. It is a non-integer. Okay. Floating, it's a floating point number that you can get very, very deep into computer science with what a float is. I like it, Desi. Root beer float. But yeah, it's a number. It's a non-integer. It's a number that has a decimal in it. Let's just keep it that way. So versus an int, which is an integer, right? And that is going to not be able to take a fraction or decimal in it. Okay, so int or integer, we use int most of the time. But float, a floating point number of digits specified in size. Okay, and I don't think we have to give that a size on SQLite. Finally, we have our Boolean, and I hope that everyone here knows what a Boolean is, and that's going to be just our true or false, right? So we've created now the fields and the types that we need for our table here. There are tons of other types on here. This is just a very basic overview from W3 Schools. If you are interested, let's go to MySQL. Let's go to documentation. We'll probably have to pick the one we want. Yeah, like, let's just go. Oh, I'm not even digging into this docs. I'd have to. Maybe Postgres will be a little bit easier. I kind of want to just look at what their types are. I know Postgres has a ton of types. Oh, there we go. Let's just go with 12. Let's go to types, data types. So these are all of the types available on Postgres. You see that right there? That's a big one. JSON, JSONB. But these are the types available to us on Postgres here in this specific. And this seems like there should be more types than that, but this might. Cool. So yeah, whatever your database you're using, jump into their documentation and check out the types for them. All right. Finally, we're going to have kind of our what we call other restrictions. So these are going to be things like, is this available to be null? So we see in these three, in ID, name, and average weight, we have given this a not null. And if we go to the DDL, we can see that we have said not null. So you have to put some information in there or else it will throw an error for us. So not null is a big one. Let's go primary key is a big one. And primary key essentially gives us that ID. Primary key doesn't always have to be an ID, but in our case for right now, it is going to be an ID. And in this case, you see we have given it the auto increment as well, which is going to add one to the last ID that was in there and have that. There are things like unique, and then default as well. So didn't give us a default on our DDL here, but we can see that our default, if we don't pass a specific default value, the default value will be null. So if I didn't pass a specific value into name when I tried to insert into fruits table, what would happen if I did not give it a name? Yeah, this one I was hoping someone would get tricked by it. So it would default to null, and then it would say, "Oh, we have a not null restriction on that," so then it would throw an error for us. Okay, if I didn't give a, and this should default to false or true if we had built the schema properly. If I didn't give a value to delicious, it would simply enter null in for the field of delicious for this record. Okay, and so like our types, there are quite a few of these not null, unique, primary key, foreign key, default, auto increment, things like that that are going to be unique to the database system we're using, but things like not null or unique or primary key or default will be pretty universal across all of the systems. They're just going to have their own little smaller things. I know Postgres has a ton of them, but yeah, those restrictions. So now we have kind of done our entire schema here. Okay, we have designed this table, and this table was designed for us ahead of time. But this is what it is. The planning stage of setting up a database is incredibly important. So when you get to labs and you're building your own database, spend as much time on planning out your database as you can, because going back in and changing things at a later time is possible, and we're going to see how to do that today, but it is not ideal. Getting things right as possible the first time is going to make your life 1,000 times easier when it comes to working with a database. If you decide that you need to go from from no not null from excuse me, that was like a weird double negative. If you don't have a not null restriction on a field and you've been using that field for a while and then you decide that you need a not null on there, then you're going to have to change it, and then you're going to have to go through and find every record that has null there and put something there, right? And so it's these little tiny things like this that compound in the long run. So spending a lot of time on schema design and spending a lot of time um, on getting that stuff right as possible. No one can ever get things right the first try. We'll always have to go back in and add something or change something later on. But as spending that time to develop our schema really is worth it in the long run. So that is schemas. Any questions right now on schema design or data types or restrictions or fields or any of that? All right, we have a minute. We have 5 minutes before our first break. So I am going to disconnect from this database. I'm going to destroy this database, and then we are going to build a new database in here from scratch. So give me 1 second. I'm going to come into our data, produce, boop. Let's just move to, oh my gosh, I can never find it. Move trust. There we go. Boom, gone. All right. Let's remove the database. Yes. Okay. So we're going to build our own database in the next 5 minutes from scratch with that same exact table on it. All right. So first things first, we want to add a database. Okay. So you can click on the add a database. You can go into database and go add a database there. Either one of those works. I believe you can also right click and then database, add a database. For now, what we want to do is we want to create a new database file. And we're going to save this as produce.db3. Okay. And where in our data? Yeah, sweet, it remembered. And then we're going to go to SQLite 3. You can do all SQLite databases if you want. We'll just go specifically SQLite 3. And notice here, we have 4 different SQLite 3 file extensions that we could be using. We're going to use the DB3 because it's kind of standard, but you can use SQLite 3 or SL3 or S3DB. All of those will create a SQLite 3 database as well. Let's save it. Let's go to tables and let's go create a table. Whew, all right. So the table we are going to create is called fruits. Okay. Okay, let's figure out how to create a column on here. Add column. All right, column name. We're going to want a primary key. Okay. We are going to want, let's go ID. Data type is going to be, if we remember, it is going to be integer or int. And where is our auto? Let's go to advanced mode. Configure. There we go. Auto increment right there. Thank you, Ryan. So if we go to configure, then we can say auto increment. Okay. Apply that. And there we go. We now have our first column on there. Let's use this to create our other columns. Next column, name. Anyone remember what our name data type was? I did not do not null. Thank you. Our name data type was text. I have variable character on mine. Let's just do varchar. That's fine. Data type, and we can come down and look. Variable character, and we're going to use 128 for this as well. And then this was not null as well, and we are going to throw a unique on this one. We only want one fruit per name on our database. So if I add apple and I add apple again, we're going to get thrown an error. Okay, so it has to be a unique value, and that's not null. And I believe I can go in here and say not null because I haven't created the database yet, thankfully. Let's create our next one. We're going to go average weight ounces. Does anyone remember what our average weight ounces was? Yeah, that was the float, right? So our average weight in ounces, and if we think about something like an average weight, we're going to think of, you're going to get, non-integers for an average weight most of the time. And so this is the type of thing, when you're designing this database and you're designing this schema, you're going to say, excuse me, you're going to say like, should this be an integer? And you're like, well, if we think about the formula we use to determine the average weight, it seems like it's going to be a float for us. So let's use float. Where did our float go? Oh, no, it's not a double float. We just write float. Weird. We'll write float in here. Let's see if it works. And in this case, we want this to also be not null. All right. There we go. Finally, let's put our delicious. There was one more. Does anyone remember what the other one was? Color. Thank you. Thank you. Thank you. Thank you. Does anyone remember what our delicious data type is? This can be only one thing, right? It's either yes or no, right? If our data is either going to be yes or no, then it's going to be a Boolean. And in this case, we don't care. And let's default to false. Let's default to false, okay? Because we didn't have a default value in there before, but I want a default value. So I want it to be false, and you need to be really certain that this is going to be delicious in order to say, yes, it is. So I'm going to default to false, okay? Don't care if it's null, because if it is null, we'll default to false. And then that should be good for our delicious. And then let's go with color. Data type, and this one we had text. So let's go text. And this one, we don't care about any of these constraints on it, okay? And there we go. We have created our schema here. I will add it. And then it gives us our DDL. It gives us our data definition language here. So if we wanted to go in and access our database ourselves and create this ourselves, we could just copy paste this whole thing in. But I'm just going to press OK. And now we have a table for fruits successfully. Okay. And then we can go into our table. We can go into our fruits. And we can go into our data. And we see that we don't have any data in here anymore. All right, that is our schema design. The next thing we're going to do is we're going to jump into our project, our guided project tonight. We are going to build this same schema using a migration, learn how to connect our server to our database, and learn how to manipulate and build our schema and preset data with connects. In the meantime, let's take a break. And we'll see you back here in 5. All right, everybody, come on back. We will continue on. So before we go any further, I will pass out this project if you would like to follow along. This is our node project that we're going to be using tonight. Yeah, you'll need to, I'll go over the steps you'll need to do to get it going. Right now, fork and clone, and then npm install, and then we'll talk about what we need to do from that point on. So let's go take a look at that code. Let's actually get rid of that for a minute. And we're going to take a look at the actual code itself. So we're going to open up our index.js. We'll see that we have a server. It's running on port 5000. And there we go, server require. And so let's go look at our actual server itself, API/server. We'll see that we have a router, the fruits router that we're using for API/fruits. And then we're using helmet and express JSON. And then let's go into fruits and let's check out what we've got going on right now. And actually, before I do that, let's create a new row. I actually don't know how to create a row on this. Let's figure this out. Form view, do you know how to do, the plus. Beautiful. Let's just go auto increment. Let's go apple. We're going to be deleting this in a moment anyways. Let's go what's the average weight of an apple? Probably like, I don't know, like 3.7 ounces. Oh, that's 3.7 ounces. Thank you. Delicious, I would say true. Color could be varied. Let's go varied. And then, do I just enter? No. There we go. Check. Okay, cool. So now we have some data in there. Let's start our server up. npm run server. Let's get nodemon going. Boom, boom, boom. Let's look at our data again. So now let's look at something we've got going on here. We are connecting our database directly in our router here. Not something we want to do, and we're only doing this right now so that we could come into our local host and get data from our server here. So now we're getting the data from our database. We see that using that SQLite Studio has actually created this value. Ooh, that's true as a, oh yeah, I guess it's JSON, so it's true as a string. So yeah, we have that now. We're actually going to come in here and we're going to delete this. And we're going to delete this because that is not good practice. Okay, we want to have a central location that we connect to our database from. So what we're going to do is we are going to use the connects CLI. We can come into connects. If you go to the bottom, you'll see their CLI documentation. You can globally install connects using npm. So if you throw the G tag, that means global. That means it's going to save it to your computer and not to the project you're in. And then it's going to allow us to use the connects command line interface, which is CLI, in our terminal to do a lot of the heavy lifting for us. So the first one we're going to use is connects init. So this is going to initialize connects into our project, and it is going to create something called our connects file. All right. So let's come into here. And then we're just going to say, if I have, if you are following along, let me write this in here real quick. Install connects and SQLite 3. I always say 2, man. Okay, run that in there. And then also you're going to want to run npm I g connects. Okay. And then you'll have access to connects. If you're wondering if you have it or not, you type in something like which connects, and that's going to show you where the connects program is located. And if it has anything there, it will tell you. If you say something like which connects, it'll say not found if you don't have it. Okay. So let's clear this. Then we're going to say connects. As long as we are in, let's do this real quick. As long as we're in our project folder, we're going to say connects init. That's what all it's going to do is going to create a connects file for us. So let's go into, let's create a new thread here. One moment. Connects file. Okay, so we have a new thread here, connects file. You can do all this stuff on a Windows machine, especially if you're more of an advanced Windows user. You can get WSL, which is Linux shell in Windows, but you can still do all this on a Windows machine. Okay, so we have our connects file. Let's go check it out. Look at this. New file has been created in our project for us called connects file. And we've got some settings that it's going to automatically give us. I had to move Zoom window out of the way. So it's going to give us some different connection points that we're going to, if we were building a production app, then we would want all of these connection points. First and foremost, we have is our development connection point. For most part, this is going to be SQLite. We see that it's client SQLite 3. All right. So that automatically defaults to us using SQLite 3 for our development purposes. For something like production, it's going to default to us using Postgres. I don't know how they came up with these defaults, but it's probably just like the defaults that the majority of open source users use, because they could probably search GitHub or something. But this is pretty standard, right? So we're going to have a development connection point. We're going to have a staging connection point. And so staging tends to be a term given for something that, if you're working on an application with other people and you're merging changes in, you're going to have a staging server that's going to be running your application for testing things. And then once you're ready to actually release all those changes, you'll have a production access point as well. For our case, we're going to delete staging and production for right now. They're just going to get in our way, and we're only going to use development. Okay. There's reasons that we have. We can use development, staging, production, etc. with our Connect CLI as well, but we're just going to use it as it stands here, just to export. So the first thing we want to do is we want to give it our client, and our client is our RDBMS. Okay, RDBMS. NS. So this is what our client's going to be. In our case right now, it's going to be SQLite 3. Connects uses this to determine how to connect with your database. So this is a connects string, and you probably, we don't have any migrates yet. Where's our connects file? There's a connects file documentation as well. Implement me. So yeah, there's client PG, client Postgres, client SQLite 3, and I should have something on here about all of the clients it accepts, but for our case, we're going to use SQLite 3. Then our connection point. If we were using a centralized database, then this would be instead of file name, it would be path, and it would be the path name to the database that we are using, along with username and password and things like that. In our case, since we're using SQLite 3, we're going to use file name because our file is our database here, right? And we're going to get rid of dev.sqlite 3, and we're going to add the path to our file. So our file is actually under data, and it's produce.db3 /produce. dot db3. And then one other thing we're going to do is we are going to add another flag called use null as default. And we're going to say true. And we need to make sure that we add our comma there because it's an object. Cool. This is all we need to connect to our database. Okay, this is all Connects needs to connect to our database. It does the rest for us, which is quite a bit actually. If you have ever connected to a database with a node server before. So Connects actually takes all this stuff and connects to our database for us. Now, one thing that we do want to do, yeah, sure, Manny. Sorry, I kind of glossed over that. Use null as default just says that if there is no actual default on there, then we're going to use null for that default. Okay, so if there's no default set, we'll have null automatically included in that. And so we saw in our structure, we have null. It also SQLite Studio also just automatically used null as default for us. If we didn't do that, what would it do? Not 100% true. Honest. I mean, not 100% sure. Honestly, I'm trying to think of what it would insert as instead. I can't think of it off the top of my head. I will find the answer for you by the end of tonight, guaranteed. And I'll write that down. Great question. Thank you. For right now, we're going to insert null as default. Okay. One other thing that we want to do, and this is a little bit of just architecting our server itself and breaking out some of the processes that aren't necessary for one of the routers over the other, is we are going to create something called a db config file. This is not necessary. I'll say that. In the fact that you're not required to do this. This is just a little bit of housekeeping, and it gives us the ability to make this connection in one place and then share the connection amongst the entire server. Okay, so we're going to make the db config file. We are more than welcome to import this connects development connection and connect it as we want to. But for our case, we're going to connect once and keep it that way. So in this case, we are going to bring in connects. Okay, we're going to require connects right now, and then we are going to require our config. And our config is this connects file. Okay, require connects file.js. Oh, need to wrap that in some strings. Of course, I did that. Okay. So we brought in the connects library itself. Look at this. There is no connects library in here. This is simply an object that has some key value pairs in it. Okay. This is not necessarily has anything to do with connects at this point yet. We're going to bring in the connects library, and we're going to bring that that object into this file as well. We are now going to create our database by passing that object into connects. Now connects is going to take that object. It's going to take all of this info in here, and it's going to create that connection, and it's going to give it back to us as that database connection. Okay, so in the last lesson, we had this as our, we had this all done for us. But right now, what we've done, remember, we just took this data, this information, pass it into connects, and it's going to give us back that connection. So we're going to module dot exports db. Now we're going to export that database connection. So now we can use this connection anywhere we want in our entire project. All right. Any questions on this or the config file yet? In our connects file thread, please. Yeah, if you wanted to do this. Instead, you totally can do that, Manny. We're just being very explicit in what we're doing here so we can explain what's going on. But yeah, you can do that. Any other questions? All right, let's move on with migrations. Let's talk about migrations for a moment, and what they are, and why we use them, and what we aim to achieve with our migrations. Okay, so in that migrations thread, can anyone give me a very high level, in your own words, what a migration is? Like it. Commit, more or less. The schema brings things together, create and roll back table creation. Yes, all of the above. Okay, all of these are correct. So migration, initially, we're going to delete our database once again. Initially, our migration is our initial schema. Okay. The thing that about migrations is, especially as in development, is that every developer should have the same database schema and database structure on their machine. Okay, and a migration allows us to commit this database schema to Git, and then as a developer, I can simply fork and clone my migration, and I can just run the migration myself, and it'll set my database up to be exactly the way it's on everyone's computer. That way we can maintain this level of consistency across development machines. We'll also use those migrations to set up our staging and our production databases as well, when it comes time for that, and to make sure that those are accurate and consistent across all things as well. And so in the beginning, remember, it's just going to be our schema. That's all it's going to be. It's going to be a way for us to write our schema in Connects. And then after that, it's going to be a way for us to update the structure of our database. And so migrations are really important. They're not going to lie, they're a little tricky at first when it comes to rollbacks and latest and all that kind of stuff. And if you do your due diligence at the very beginning of your project, and you spend a lot of time on planning, then you will not have to use migrations a whole lot. You shouldn't have to, hopefully. If you don't do your due diligence at the beginning and you kind of just roll with it, then you're going to be writing a lot of updates and a lot of migrations, and things are going to start to get a little a little weird, and not weird, but they're going to start to get a little confusing. So hopefully you don't have to do a lot of rollbacks. Hopefully you don't have to do a lot of new migrations, but it'll happen at some point. So let's look at the migration API. It's way better on our under the CLI. So you can write your own migrations in Connects, but we are not going to. We are going to use the Connect CLI. But this is a great resource right here. It's the migration API because it gives you all of the options you can use in your migration. Okay, it takes an optional config object which may specify the following properties. So it is important to understand kind of what's going on with this stuff. But let's go into the CLI real quick. So first things first, sorry, before we do that, we are going to create a another option on our connection, and we're going to call it migrations. Migrations. And then we're going to say directory, and we'll say data, .data / migrations. And you're going to be like, Dan, there's no directory called migrations on data. I don't know what's going to happen. The cool thing is Connects is going to build that directory for us automatically. The same as it's going to build our database for us automatically when we delete that in a minute. So now that we have that set up, and I need to set one more thing up that I apologize for not doing, but in our fruits router, we are going to const db equals require. And does anyone remember where our database connection is at? You can throw that in the migrations thread. Remember where our database connection lives? What file it lives in? Yeah, so that data / db config file, remember? So we will say data / db config.js. And we don't have to do .js, that's fine. Okay. We'll put that on there just to be explicit about things. All right, so now that should work. We're not going to touch our fruits router at all anymore. We're done with it. Let's actually test this thing out just to make sure we don't have any errors. Let's go in. Let's refresh this. And we got it. Okay, everything's working the way we want it to. Our Connects is connected to our database, and it's serving up the right information for us. Cool. Okay, so let's come into our CLI. Let's get rid of that. Let's clear this. Clear. Oh my gosh. And we're going to write our first migration. Okay. Let's see. Should I have deleted this yet? Yes, I'm going to do that first. One more before we do this. I want to delete this. Disconnect from the database. Make sure we disconnect from the database always before you delete something on your database. Wait, there we go. Okay. Throw that back in the trash. And let's get rid of that for a second. All right, we don't have a database anymore. Okay. We can try to connect. Let's give it a minute. It'll automatically create it for us once we try to connect to it. So we don't have a database, but and so all of our schema is gone. Everything's gone right now. Okay. So first thing we're going to do is we're going to say connects migrate want to make this bigger so you can see the whole thing without it wrapping. And then we're going to use a colon, and we're going to say make. Okay, so connects migrate colon make. And the migrate is always going to take a colon and then an instruction after that. And we're going to see like latest or rollback or make, etc. So this is going to make a new migration file for us. And then we're going to call this fruit schema. Using development. I hope it did it right. There we go. We have now look in our data directory, we now have a migrations directory. And if we open up this, we are now going to see that we have this shell here. We're going to have an up and we're going to have a down. Who thinks they can guess what up versus down means? What I'll just say this. What does up mean in our case here? Any guesses on what up means? Upload. Yeah, it's great. Great guess. Yeah, up is going to be applying the migration. Okay. So we're going to do something in here that we're going to apply this change to our database. All right. Down obviously is the opposite. It is going to be our rollback, and we'll see a rollback in a moment. If we changed our database and we're like, oh no, we like totally screwed up and we meant to do this other thing, we can actually roll it back, and that's where our down is going to come into play. So we're going to want, for everything we do in up, we're going to want to do the opposite in down. Okay. Let's look at connects, and we can look at our schema builder. So our schema builder is we've been dealing with our query builder this whole time. This whole time as in last lesson. Tonight we're going to be dealing with the schema builder. Okay, so we're going to have everything that we can do. Create table, right? We're going to do all of our types are going to be in here. Timestamp, time, date, time, Boolean, etc. All of this, and we're going to see how we can incorporate this in a way. So once you know how to incorporate it, then you can start chaining things together and to create your table. Not nullable, all right? Unique is in there. Cool. Let's come into our up. And this is a little, we're going to need to also include promise in here. This is a little tricky, but our up is going to actually return the connects, the schema builder itself. So we're going to need to return, and then we're going to say connects dot schema dot, and what we're going to do here is we're going to create table. If you were updating the table, there should be we have rename table. There should be there's just a regular table. You can come through here and find everything you need to do. But this is how you go and change the name of a field, or you add a field, or you remove a field from your table. Okay. So in this case, we're going to create a table called fruits, right? And this is going to take a callback, and the callback is going to be passed the new table. Okay. So create table is going to create a table with this name, and it is going to give this callback the new table before it does it. So we're going to call this TBL, which is what you're going to see in the documentation. And now we can start to manipulate this new table. Right now it has no rows, it has no information, it has nothing on it. Okay, so we're going to use the table, and let's go look at the where's it at? I'll search. Oh, there it is. I couldn't find it. Increments. Increments adds an auto incrementing column. Okay. in Postgres, this is a serial. In Amazon Redshift, it's an identity, blah, 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 blah. So this is going to be our ID, essentially, right? If we don't give it a name, it is going to default to ID, right? So we are simply going to write tbl.increments. That's our ID. That's our primary key, and then it auto increments for us. Then we are going to add. Let's talk about real quick. Let's figure out what our fields were. We had name, we had average, weight, OZ, I believe was called that. We had delicious. We had color. I don't think I'm missing anything. Am I missing anything on this? Name, average, weight, OZ, delicious. Oh, we're not going to do color right now. We're going to give that a minute. Okay. Let's create these then. TBL dot. In this case, what we do is we're going to give it the type first. So the name, we used varchar or text. We'll just use text right now, but we can see we can use there should be a variable character on here, but we're just going to use text for right now. There's our text. Adds a text column. Okay. And it gives us the type. We're allowed to use the type. There's also a string, float, decimal, Boolean, date, etc. All of our types are in here. So we're just going to use text. And then when we call this, we're going to give it the name. In our case, it's going to be name. And we can give it an optional character count. So we're going to say 128. And then remember, we wanted our name to be unique. In Connects, it's really easy. We just say unique. And remember, we also wanted it to be not null. So in Connects, we use the not nullable. And that's it. Now it's going to create this field for us using the text type. The name is the name of a field. It's going to be 128 characters. It's going to be unique, and it's going to be not nullable. Okay. Pretty cool. Pretty simple way of building our schema. Otherwise, you saw that DDL from SQL Studio. That's how you would create it normally, is writing it by hand. Okay, the next one, we're going to use float. And this one is going to be average weight, OZ. And we wanted this, did we want this one to be not nullable? Gotta think. Yeah, let's do that not nullable as well. Okay. Finally, we wanted our Boolean. And I'm going to assume that they're going to allow us to use bool or Boolean as a whole word. I can, oh, they need to do these in alphabetical order. That would make things so much easier. Boolean. Oh, only Boolean, huh? That's weird. Okay, so we're just going to use the whole word Boolean, and then we're going to give it delicious. Yeah, we can do required. So let's go look at, gotta be on here. Sorry. Let's go look up, see if we can find a required. Not. I don't know what the is required. I'll find that out in the break as well, what the required one is. So I don't see it on here. And so I guess required would be not null, right? Yes, yeah, not nullable makes it required. Yeah, cool. I think Manny and I came up with had the same wavelength there. So not nullable makes something required, right? If it's null, then it's not there and it's required. Okay. Cool. So then this is it. That is our migration. That's our entire migration. We're going to create the table of fruits. It's going to create an ID increment. It is going to create a name field, an average weight ounces field, a delicious field. Final thing we need to do. What's the final thing we need to do? Does anyone remember what the final thing we need to do before we migrate this? Default value for a Boolean. Yes. Let's go default 2, and then we can give it the value. Cool. Final thing we need to do other than the default value for the Boolean. Oh, I kind of gave that up. Yes, our down function. All right. So in this case, what are we doing in our up function? Like the general idea, what are we doing in our up function? That's a question for you all. Yes, we're creating a table. Okay. In the grand scheme of things, we're creating a new table. So in our down function, we should be destroying that table. We should be removing the idea of that table from our database. So we're going to next schema dot, and we're going to use something called drop table if exists. Okay. Sometimes when we go to run our up, we have a mistake in here and it doesn't work. Okay. And we'll get an error and it won't work. But it'll still try to run the down. And if the table doesn't exist, then we'll get a super big error and it'll freeze our entire thing up. So we're going to say if it exists, if the fruits table exists, then drop it, because that's what we've done in our top. So that's what we're going to do in our down. In our up, we're going to create the table. In our down, we're going to drop the table. For those that are unfamiliar, drop table means delete the entire table from your database. Okay. So don't drop table unless you really mean it, because like every other thing in SQL, it's permanent and you can't reverse it. And let's go back and give our promise here as well. Not 100% sure we still need promise here, but for legacy purposes. Cool, Manny, I'm going to show you right after the break. Let's take 5, and then we'll actually migrate our migrations. We'll see you in 5. All right, come on back. Let's finish this thing up. Let's get our schema migrated and let's throw in some seed data into our database as well. Okay, so when we left off, we had created a migration for our first table into our database. Notice that we still do not have a database. Let's npm run server. We should get an error. Nope, didn't get an error. I'm kind of curious why we didn't get an error, because Connect should have tried to connect to our database. Maybe if I do this. Yes. Failed to retrieve fruits. There we get an error now. But look at this. Connects new and it made our database for us. I'm going to delete that again. Yep. I'll throw the third produce database into the trash. Okay. I'm going to turn my server off. So when we connected to it, Connects knew that we didn't have a database there yet, so it created that database for us. Okay, but it still didn't have that fruits table in it. In order to create the database and add that fruits table, we are going to use our migration CLI once again. And instead, this time we're going to say migrate. And we're going to say latest. Okay. And when we do this, now it is going to create the database for us. So we see we have that new database again, and it is going to create that table for us. If we don't see any errors, batch one run, one migration, then everything is successful as far as Connects is concerned. If you have multiple migrations to run, it will run all of them. Connects actually creates a table on your database that stores the migrations that it has run. So a lot of times we're going to see, if I try to run latest again, it won't run anything. It'll be like up to date. Yeah, let's do that. Already up to date right there. How does it know that? Well, it actually creates a table on your database to store that information. So there's a small table on your database that's storing that. And we can, let's see. We can see there, Connects migrations and migrations lock. And we'll go do data. We'll see. So it's telling us that it has already migrated that. It's given us that timestamp fruitschema.js file, and it tells us when it migrated it. So that's one thing that Connects does automatically as well. All right. So now let's say that we did not. Let's go. We did everything pretty good actually on our first time. Let's go. What did we not do? No, we got everything. The only thing we didn't do was add our color, right? And so we're like, oh no, we didn't add our color, our color field, and we're like, we want to add a color field. Okay. What we could do is we could use our rollback feature. All right. So instead of latest, we could say rollback. And rollback and should undo the last migration that happened. Okay. And so what happens in rollback? What is called on when we say rollback? Anyone know? Yes, Manny, our down. So that's when our down is called. Okay, when we say like, oh, whoa, we didn't actually mean that. We want to roll that back. Then our down is called, and then we should. We should have something in our database, but I don't see it in our database at all that we have rolled it back. Index one. Maybe it's our migrations lock that we're still on 0, right? So now we can come in here and we can say table dot color. Oh, not color. Table dot. We'll just use text in this case. Color, and we're not going to do anything special to it right now. Okay. All right. So let's come in there and let's look at our fruits. It says like, I don't know what fruits is, right? Could not process fruits table correctly, unable to open the window. So where's our refresh? There we go. It should have dropped that completely. I'm surprised that it's still on there. Okay. Okay. What is it? Refresh all database schemas. There we go. Okay. Now our migration's still there, our lock is still there, but our fruits table is gone. Okay. So let's go back into our migration CLI and let's go latest again. All right. We'll refresh again. We'll see that we have fruits now and that we have color as text now. All right. So, question for you all. What's wrong with actually changing our database, our migration like that? Does anyone think of anything that like stands out that could cause an error by rolling back and then changing something? And it's not going to be explicitly evident right now when we're doing this. Yes, other users won't have the latest. So let's say we sent the migration out and get all of our other users, migrated, and then we're like, oh no, we wanted this other thing, and then we change that migration, and then we commit that. Those other users aren't going to have that same migration. They're going to have to roll back and do all that stuff as well. So we're really only using rollback like in the moment, like, oh, maybe we forgot to do something right now. Okay. And I'm actually going to roll it back again, and we're going to see how we would do this in a production environment. Okay. I'm going to roll it back, and I'm actually going to delete that color. Okay. Save it, and then I'll update it again. All right, so now we should have no color on there. So we're really only going to roll back when we're doing something and we've changed it and it's only on our machine, and we wanted to add something else. Okay, if this is something that has already been committed to Git, we're not going to roll back. All right. Name field is not unique. I'm not sure. That's weird because I said unique. Let's go see. Yeah, it should. Not 100% sure of why that didn't give it the unique flag on there. Also, that's weird that it didn't roll that back properly. Roll back. This might be an error that we can't fix. We might need to. Yeah, so it still knows the migration, and it knows that we added that color to it. So we are going to get that color back, and we're just going to add a new field in a minute. Okay, so yes, we don't want to take anything off of our migrations like we saw there. I'm not 100% sure why it still remembered that color was on there, but it did. okay, because it keeps that lock in there. There it is. Okay, maybe I was wrong. I thought it kept the lock in there. Okay, I know I've run into issues like that in the past. These migrations, like I said, can get a little tricky in how they work and this rollbacks and all this kind of stuff. But for what we want to do is we instead do not want to roll back and change that. We want to create a new migration. So in our case, we're going to create a new migration. Connects, migrate, make, and then we're going to go fruits, color. Okay. So now we've created a new migration called fruits color. All right. And it's going to give us that timestamp as well when we created it. And let's come into here. And now let's simply get our table and let's update our table. All right. Really simple to get our table now. I'm going to add that promise again. Like I said, not 100% sure if it's still necessary, but that's legacy. So I'm going to say connects.schema.table. And this is going to get our table, give it back to us, and allow us to change it. Okay. And we're going to give the name of our table, fruits. And once again, it's going to give us the table back in the callback. And it's going to allow us to add whatever we want to it. All right. Really cool. To update it and to change a table using standard SQL is a bit messier than this. Okay. So yeah, it just allows us to now go in here and change our table. We want to add that color field to it. And we already committed our our migration to Git, but we wanted to add this color field to it. Once again, we're going to return connects schema dot table. Once again, we're going to grab table, and then we are going to give it the name of the table. The table itself is going to be returned to us, and then we can say table dot drop column drop column color for if we ever need to roll back. And there is our schema there for us in our second migration. Remember, the create table's there, and we're manipulating a table here, so we're just using dot table, and it's passing in the name of the table, and it's giving us that table back and allowing us to manipulate that table as we please. Okay. So once again, we're going to say connects migrate latest. That is going to find everything that hasn't already been migrated to our database. All right. And now it's going to say batch 2. Okay, we've already run one batch. Batch 2, we have run one migration. And if we refresh, we'll see that that color table has been added, or that color field has been added to our table. That is migrations. Okay, that's how migrations work. If we need to make changes, then we make a new migration. All right. The only time we don't need to make a new migration is if we have not committed that migration to Git yet. And even then, if you create, most of the time you'll create one table per migration. And so, you might be like 13, 14, 15, it might be 70 migrations in. You don't want to roll all the way back. You just want to create a new migration, and you want to update there. So that every time, if you pull anything down from Git, you can just run connects migrate latest, and it should totally work on your machine that way. Any questions about migrations at the moment? The CLI command I used to create the new file, Melissa, if you're referring to the connects file, that was connects init. If you are referring to the migrations, it is connects migrate :make and then the name of your migration. Michael, the best practice is to do one table per migration. That way you can roll back if you need to, but you don't have this monolithic thing. I've done both. I highly suggest one table per migration. Yeah, okay, Melissa. Yeah, so it's the same as creating your initial migration, right? It is just migrate, make, and then originally we said the name of our migration, if I can find it, was fruit schema. That was our first migration, right? That was our initial one. And this one was fruits color, right? And so you just give it a name of what you're doing, but it's the same for both the initial and the new one. So migrate : make, and then the name of what the migration is. And I'm not gonna lie, the documentation for this stuff is not the best. This is not Connex's strong suit. The documentation. Although everything we talked about is in here, so we can see how to create a new one. It doesn't have a whole lot of why rollback and how this stuff works and latest and all that, but you can see their document. It's okay. It's pretty decent. So you can do rollback all. You can use migrate up, which does one at a time, rather than latest does everything that hasn't been migrated yet. And you can undo the last migration by rolling down. There's a lot of different things you can use. And this one, I think they've actually improved it recently because it wasn't this in depth before. All right, let's move on to the final topic of the night, which is seeds. Who can tell me what a seed is? And if we know migrations, we can do seeds pretty quick, pretty easily. Yeah, dummy data, starter data, initial data. We call it seed data. Okay, we plant the seed essentially, sample data. Sometimes this data is data that you are bringing over from somewhere else. Sometimes it is, default data that you need in your database for your application to run. Sometimes you're going to do this just as for development reasons. So you can just get going really quick and start writing your code rather than having to deal with writing a bunch of dummy data into your database. So it's very similar to our migration. In fact, almost the same, except we're going to use seed instead of migrate. In Connect's file, we are going to say seeds directory. I'm going to go data/seeds. And that's it. Okay. And then in our CLI, we are going to say connects seed make, and then we're going to give it a name. So very, very, very similar to our migrate. We'll go at fruits, our first fruit. So we're going to say connects seed make fruits. Okay. And now it'll create a seed file where we asked it to. Okay, we have, let's close that npm. Don't know why that ever opened. And let's look at our seeds. And now we have a seed file. Notice it doesn't have like the timestamp on it. Why do you think it doesn't have that timestamp on it? That migrations does. Any guesses at all? Yeah, I mean, migrations are a little more important, right? Connects understands that migrations are more important. They actually manipulate our database, the structure of our database, whereas seeds is just kind of throwing some data into it. And so we don't really have to worry about rollbacks and things like that. with our seeds, and we're actually going to show how you can roll back with seeds with just using code, essentially. So we see here that Connects gives us a pretty good starting file, right? This is what Connects built for us. So we can kind of just follow along here. Our table name is going to be fruits. And then we're going to have delete here. Why do you think we're going to have delete? Well, it tells us that right there. I guess I don't have to ask the question. It deletes all the existing entries, okay? If you don't want to delete all the existing entries, I guess it wouldn't be a seed file necessarily, but you don't have to include that. All right. But that's what it's going to do. It's going to delete everything in there to begin with. Is it going to delete the table itself? Question for you. Will it delete the actual table itself? No. Remember, drop table actually deletes the table. Delete, remember, if we think about this, let's instead of saying connects here, let's say DB. And remember, this is going to be essentially a delete without a where. Okay, so what it's going to do is it's going to find that table and it's going to run a delete on it without your where. And remember from Tuesday, if we use a delete without a where, then it's going to delete all the records from the file. Okay, so that's what it's doing there. And it's going to say once it's done with that delete, then we're going to insert some stuff. So we're going to insert into fruits. And we're going to insert a bunch of data. And I'm actually going to copy paste this data over because we ain't got time to type it all out. And it's the same data we've been using all night. Okay. Make sure that I got all of my stuff right. Otherwise, we're in big trouble. Let's see. OZ, name, delicious. Okay, I think I got it all right. If you know, something like if you have a casing error on one of your fields, it's going to throw back an error and not run your seed. Okay, color, true, float. Okay, cool. We should be good. And so, yeah, you're just going to essentially write your data as you would expect it to come back from Connects in some sort of in some sort of a query, right? And I'm actually going to remove this because I want to show you something real quick before we leave as well. So if we want to run our seed data, we're going to say connects seed run. And that's it. And it's going to find all of your seed files in that seeds directory, and it's going to run them. And we must have done something right because everything good came up with no errors. Let's make sure that we got this. And let's look at our data, and our data is in there. Okay. All of our data is in there. So that's a seed, okay? Are there any questions right now about seeds? It's pretty simple. Actually, just running Connects seed make really gives you a really good head start. Connects just kind of lays it out for you, like this is what it should look like. This is how it should be formatted. Any questions? Questions on seeds? I'm going to take 2 minutes of your time after 30, but they're pretty simple, right? And if you don't think it's simple, that's totally fine. I would love a question. All right, while I'm waiting for questions, I want to show you something. Can I do this again? Do I have to roll back? That's a question for you. Do I have to roll back, or can I just run this seed again? Yeah, remember, I can run it, right? Because it's actually going to do its own rollback for us with that delete, okay? So I can run it again. Watch something crazy happens. Not crazy, but look at our IDs now. So our IDs, our database knows where it left off with IDing items. Okay. If we do a rollback, or if we do a new seed, we're still going to get the same data everywhere, but we're going to get different IDs for that. If we are worried about that, we can do one little thing. And I'm actually going to post that thing back there. I just didn't need to do that. But so instead of delete here, we can use the truncate function. So we can say truncate, and truncate's going to do essentially the same thing as delete. It actually is going to remove those from the. It's going to remove the actual rows from the memory. Okay, and so actually in this case we should still see 5, 6, 7, 8 because that would be where it was truncated. Well, let's see. Let's check it out. Let's run it again. Make sure that I saved that. Okay. No, we got it back. Okay, so now we got our back from scratch. Okay, so that's one thing. If you're concerned with that, if you're some people are using their own ID system for it, and that's totally fine. You don't even have to worry about this about using delete there. But in this case, truncate actually resets the IDs as well. So that's it. That's all we're doing for tonight. You could go in here and refresh. Oh, got to turn the server on. npm run start. And there we go. We've got all of our beautiful fruits. Some of them are delicious. Some of them are not. Durian's average weight is 52.9 ounces. That's crazy. But cool. That is migrations, schema design, migrations, and seeding with connects. So as you can see, there's quite a bit of work to do on just setting a database up. You know, and it is work that pays off in the long run, like I mentioned. But you know, you really have to be able to shape. You have to understand what data you are wanting to store in what format, and you really got to spend some time working on that. And then, like I said, in the long run, it'll pay off. In the short run, if you don't spend that much time working on it, you're going to be a lot of headache and a lot of what we call technical debt in the future, coming back in and changing little tiny things like, oh, that was supposed to be not nullable, or that was supposed to be null, right? That type of stuff. So it is a little bit of work, but it's worth it in the long run. And then you got a database set up, and then you can use it to your heart's desire. But that is setting up a database and schema design. And that's what I got for you tonight. Sean will be back next week. Thanks for letting me hang out with you this week and do these couple lessons. It's been great. Have a great night, everyone, and I'll see you later.